Let's review, okay? 4 types of decision support systems. And by the way, just as a minor note, like how many times have I told you that there are 4 types of decision support systems? I've lost count of how many times. You're probably thinking by now, man, I'm sick of this. We know this already. Number 1, you probably don't know it actually as well as you might think. And under pressure, sometimes things you think you know, you don't know. Okay. Secondly, the way that we learn stuff well is by repetition. Actually, ironically, or maybe not ironically, but very deliberately, that's kind of what this today's topic is about: repetition and its importance for learning. Okay. So let's do the 4. Okay, and I'm actually going to elicit something important out of this when we have a look at them. Start with the simplest. What was the most basic kind of decision support system we looked at? A spreadsheet. Okay, good. Upper level of complexity and cost. What was next? Relational database. And most recently, we spent a little bit of time looking at exosystems. Yes. Not to be confused with the humans, who we call experts, right? So the idea was, from 1 to 3, right, we're getting increasing levels of sophistication, right, which is great. They can make more, a broader range of decisions and more complicated ones, but you get this added level of complexity in how much time you've got to build and design these kinds of things, right? A spreadsheet we could knock together in a few minutes, and it can be quite simple, do the job just fine. Whereas an expert system, these kinds of things, they need teams of programmers and knowledge engineers and the actual experts in a domain to make one of these. Okay, come in. Morning. Now, here's the thing though. For all of their differences, okay, there's one key weakness that all of these types of decision support systems share. Okay, and it's that when you want to make something with these, number 1, and number 2, when you actually want to use it, right, it requires a tremendous amount of human intervention. Okay, so number 1, you got to design the thing, right? And then often to use it, you have to give it very specific kinds of inputs and that kind of thing in order to get something meaningful out of it. Okay? And also, as the situation might change, or you need some adaptation, right? You're going to have to come back to this human design, right, in order to make updates to how the system makes decisions, okay? So suppose we learn something new about, say, weather, okay? Some groundbreaking new discovery, and so our system that we were using to predict weather, right, is going to have to be manually updated and changed, and that's probably going to be a very complicated process, okay? So, that's a real challenge, right? And it runs contrary to the basic way that us humans make decisions, right? Namely, that we learn and we change. And after making many, many decisions, that's how you get good at making decisions. That's how experts become experts, okay? So, that's what I'm getting at here. What's the main drawback, shared in common, between all 3 of these previous types of decision support systems? They can't change of their own accord. Okay? If we want to update them, if we want them to be better, we have to do it ourselves, right? And from a programmer's point of view, if you've got a system, all the things that it can do are things that you have taught it how to do, right? Every function, every actual operation that it can do is specified by the programmer. Okay, that's in a traditional sort of view of programming. So